Hi everyone, and welcome to our video on finding the relationship between polar coordinates and rectangular, and then converting polar to rectangular. So in our relationship, we often still sketch an XY axis, and I haven't labeled it in the previous videos, but on this I will. And if we plot a point somewhere, we know that we can label it as XY, where X is that horizontal distance there, and then Y would have been the vertical distance here. Okay, so remember, those are measuring horizontals and vertical distances. Well, if we plot it using our polar coordinates, we know polar coordinates are measured from the center to the point where we say that length is r, and then we have an angle. Let me do it in purple. We have an angle theta right there. So we have r theta is the other way that this can be written if we're doing polar. Okay, well, we might say, well, there's combining the x and the y. Let me now do it in green. Or I say, well, that measurement, the horizontal measurement is x there. I made a right triangle, and I know that vertical length is y. So it looks like we can use SOHCAHTOA and Pythagorean's theorem to see a connection between the two different variables that are involved in each coordinate system. Okay, so SOHCAHTOA, our sine of that angle theta would equal opposite, which is y, over the hypotenuse, which is r. Our cosine of theta would be the adjacent x over the hypotenuse r, and our tangent of theta would be opposite y over x. Okay, so we have these different formulas. What I'm going to do, I'm going to rearrange them a little bit. So for instance, I'm going to take the cosine formula and multiply each side by r. If we do that, our x would be by itself. So if I multiply each of these sides by r, those r's would cancel. And then let's put x on the left. X would be equal to r cosine of theta. If we do a similar thing with the sine equation, multiply both sides by r, we would have y is equal to r sine of theta. Okay, so this is showing if we have r and theta, we can get x and y. Okay, so for this, with r theta, we can convert to a rectangular. It would be the x coordinate and the y coordinate. Well, that would be r cosine theta, comma, r sine theta. Just like that. Okay, so if we have a polar, so this is going from polar to rectangular. So polar, and then my little arrow, rectangular. Okay, so that's how we can convert it. And then now let's use our tangent, but also our Pythagorean theorem. All right, so our Pythagorean theorem based on this triangle would be x squared plus y squared equals r squared. But one thing they might like to do in these problems is square root the r, and then, or square root both sides, and then just rearrange it to put the r on the left. Okay, and then we choose the sign. Usually we choose the positive to make things easier. Okay, so, but it's up to you. If you want to do a negative radius, that's fine. You just might have to adjust your angles. Okay, so this, I am going to write it as r is equal to plus or minus the square root of x squared plus y squared. And then I'm going to put my tangent formula down here as well. So tangent of theta equals y over x. Now with these two, notice that our x's and y's are on the right side, and then an r and a theta is on the left. So this would mean if we have our rectangular, we could convert it to polar by using those equations. So eventually we can get r and theta, where r is the plus or minus the square root of x squared plus y squared, comma, and then theta looks like you could do a tangent inverse, but you'd have to be careful with the angle. Okay, so I am just going to say tangent inverse of y over x would get it, but I'll show different ways when we start to do the problem. Okay, so there's all this set up to show the connection between the two. All right, well, let's convert our polar to rectangular. Okay, so our polar, this is an r and this is a theta. What I would do on these problems is still sketch it no matter what. And a lot of times they're using nice angles on the unit circle where we might not need to do too much math, like the special triangles can take over. Okay, but 5 pi sixth is somewhere over there. So here's 5 pi sixth, and then a radius of 12. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so my tick marks might get a little lost there. Okay, so, but it's not that big of a deal. I just wanted to kind of show I was going 12 in that direction. And remember, this would be going negative. So -1, -2. Okay, so this is +1, +2, so forth. Okay, so that's where it is. So we can see it's in quadrant 2. And even from here, we can use a special triangle to figure out those links and then just make sure that x is negative. However, I think it might be a good idea to try to get used to our conversion. So we know if we have r and theta, we can change it to be x and y because we know x is r cosine theta and y is r sine theta. And then we'll just plug those numbers in. So we have 12 cosine of 5 pi sixth, 12 sine of 5 pi sixth. And then we can evaluate those trig functions. So we'd have 12, and then cosine of 5 pi sixth is negative radical 3 over 2, comma, 12 times sine of 5 pi sixth would be 1/2. And then we'll simplify one last time. We get negative 6 radical 3 and 6. There we go. Okay, and if we use the special triangle on this problem, so I'm just redrawing this out, we know that this length is 12. If we converted things to degrees, or even if we didn't, I think degrees would be easier. This would be 30 degrees. And so that means we should half the hypotenuse to get the smaller side, and then multiply that one by radical 3 to get the medium side, because it is the 30, 60, 90 triangle. So if you do remember the 30, 60, 90, they can be helpful on this problem. And then afterwards we'd say, well, the x coordinate should be negative because quadrant 2. Okay, so we can get that match. However, I think this that I wrote is stronger in the long run of things with our trig. Okay, so the special triangle is fantastic a lot of the times, and you can use it to double check. But I'd say on this problem, it might be best to try to just convert it right there in that equation. All right, now number 2. This time around, I'm going to jump straight to the equation. So there's our r and theta. And I know it's still, let's write out our full equation for each coordinate still. So r cosine theta, comma, r sine theta. And then we'll sub those in. So square root of 5, cosine of negative pi quarters, comma, square root of 5, sine of negative pi quarters. And then we'll evaluate that. So we have square root of 5. Cosine of negative pi quarters would be square root of 2 over 2, comma, square root of 5. Sine of negative pi quarters would be negative square root of 2 over 2. And then we could say, well, the square root of 5 and the square root of 2 would multiply, because you could put a 1 down here as a placeholder. So that would be the square root of 10 over 2. And then the other one would be negative square root of 10 over 2. Okay, so there's jumping straight to it. Now, I would still say probably plot it. So I just changed the order just to make sure the signs are correct. So a negative pi quarters would put us down in quadrant 4. And then we would want to go a length of the square root of 5. Well, it's somewhere maybe about there, so a little bit past 2. And all we're doing is double checking the signs. Yeah, positive x coordinate, negative y coordinates, looking good. Okay, this is also another special triangle. Okay, because this would have been a 45, 45 with the hypotenuse is 5. And then to get one of the legs, we would have divided the hypotenuse by the square root of 2. Okay, so then that would have been the square root of 5 over the square root of 2. And then notice if we rationalize it, it matches the radical 10 over 2. Okay, and then afterwards we still just, this would also have been the same because it's 45, so it's isosceles. Okay, so still rationalized, still radical 10 over 2, but it'd be negative because it's in quadrant 4. So the x coordinate's positive, y coordinate's negative. Okay, so that's how we can do these, at least the one part. Let's convert these in a different video. We'll scroll back and start up here just to point those out, but that's that. So thanks for watching. Please let me know if you have any questions, and see you next time.